I've always been a really shy person, so you probably haven't noticed, but whenever I go into a room, I like to sit very far back to be hidden. And when I was about 13 years old, I went from sitting in the back of the class to sitting in the middle of the class to sitting to the front of the class to looking at the overhead projector and the teacher asking me, "Are you having vision problems?" And I said, "No." But then I went to the nurse and found out I indeed had a sight problem. So I went and got my eyes checked and got my first pair of glasses and realized what a gift having those glasses were. Not everybody has to wear glasses, but from wearing a zero prescription or plano lens for like sunglasses to a high -12 or 13 or +13, it's the same process. So today I wanted to take you through a how it's made episode of how glasses are processed and developed for you to wear. The first thing you need to do is you need to go to your optometrist or an ophthalmologist and get your prescription. And if you have seen one, I see a lot of you guys have glasses, you will have an OD and OS, which means ocular dexter and ocular sinister for left and right, that's Latin. And then you'll have your sphere, cylinder, your axis power, and if you need it, an add power and an intermediate. So what that means is, and the numbers you see are called the diopters, which is a refractive measurement of a lens or a mirrored surface. So you would give this to your eye care provider or like say lens crafters or eye masters and give it to them to manufacture it. And the first thing that they're going to do is they're going to measure your eye distance, your pupillary distance. And the importance of this is that your eyes sit in a certain spot. So you're going to pick your glasses and your eyes have to sit in a spot. And the stronger the lens, the focus of power is right where your eyes are. So if you move it over, you induce prism, which means that it will pull the muscle of your eye this way, or it moves it this way, or this way, which will make it impossible for you to see, or you'll walk dizzy. So when they put this information into the computer, it comes back to the lab or the manufacturers. And what they'll do is that depending on the power, they will select a lens blank. So we can start with, let's say a -1 with quarter cell in it. And the base power of the front curvature of the lens is normally starting at a 6. So to do the math, it's basic algebra. So if the front curve is a 6 and you are a -1, what you want to do is make a -1 from that distance. So your tool, which is usually a metal blank, is going to be a -7. So your -6 on the top, your 6 curve, and your 7 on the bottom will give you a -1. And reverse, if you're going to go plus, your 6 curve will be a 5 tool on the bottom. So it gives you the +1. If you're doing cylinder, again, it would be algebra. So you say you have a -1/4 cylinder, you're going to minus that on axis. So you'll see an axis. So think of your eye as like a pie chart. And in that direction is where you need that extra quarter of cylinder. So that's also important. So when you are laying out your lens, you're going to put your axis, and then on your tool, so we'll say I need a -1 -1/4, I'm going to have a tool that says -7 -7.25. Make sense? Mm-hmm. Okay, so you're going to go in there and you get your lens blank and you mark it. If you have a bifocal, which means that you have a hard time seeing in distance, it is measured a certain distance below. Another reason why you need your pupillary distance to know where your bifocal has to sit. So when you look down, it's at the right measurement. Okay, so moving onward, you mark it, you have to tape it, and then it sticks onto a chuck. And the way you do that is there's molten lead that you pump into like a little hole in it, and then it sticks it to it. So you always have to wear gloves because you don't want lead all over your fingers. And then you take it over to a generator. And depending on your lens material is how there's a grinding stone that cuts your lens from the back side, because you never want to touch the front side because that's already manufactured by the manufacturer. So you put it in this big machine, you chuck it in, and then you will dial in your curves. So you dial it in, you close it up, and if you have glass, it has to have coolant because it gets hot and will crack it. The newer machines are for like plastic and polycarbonate and high index lenses. These are different types of materials. Can be done dry, but if you have an older lab that does glass, they will usually do it in the same thing that has a fluid that washes it all off. So you will cut your lens in, and there's certain thicknesses you have to get to, given a little bit of leeway so because you polish them. So that polishing will take off even more time, more thickness. And once you do that, you have to put it on the polishing machine. There's 3 steps. You go through a hard grit, a finer grit, and then a polishing pad. Once it's done, you go to the sink. There's this little like PVC thing, and you pop the chuck off, the little lead piece on the back. And then you have to look through a lensometer to measure the prescription and make sure it's right. Once you're looking through there, you're also having to dot where the center of the eye of the power is. And then when you take it to another chuck machine, which will put a blue tape where you can stick it into a machine that will cut it down. You cut it down to your lens shape, you take it over, and a lot of materials are UV protected already. The only ones that are not are basic plastic and glass. And that can be remedied by adding a UV dye. And there's also many other coatings that you can put on your lenses. When that's all said and done, you can tint your lenses. Make sure though, I'm gonna tell everybody, if you do get tinted lenses, make sure you do have the UV protection, because if you just tint them black with no V, you're basically opening your pupil wider to get lit in the UV rays. But like I said, if you get polycarbonate or high index, it's already covered. And then when it's all done, you do a final checkout, add another lensometer, and you can only do this if you are certified with the American Board of Optics, and you check the prescription again and put it through. So when you go through, it's finally dispensed out by the optician, who will put your glasses out for you. I have found that a lot of, when I went back into the optometry field again, that kids were having to get bifocals because they were reading too much at their computers or their handhelds. So one of my tips I would like to give you guys is that if you could take 10 seconds out of the day to look 10 seconds at something 10 feet away and then back, and then just give your eyes that exercising so that you can keep them from having to wear bifocals for that much longer. So I wanted to show you guys my contact glasses. These are my special driving glasses. They are a polycarbonate brown, so it has a filter for, oh shoot, what's the word? It has a filter inside that blocks the UV rays. It also is mirror coated to bounce off extra UV red. It has anti-reflective coating on the back, so that glare from the back does not bother me. And I can also look at glare from cars and stuff when I don't see them. So when I put these on, my eyes do an instant, oh. So I just wanted to finish off and hope you enjoyed how it's made of glasses.